Right, so you're learning how to find the least common multiple between two numbers given. This is a great problem that demonstrates that. Hot dogs come in packs of 8, buns come in packs of 12. How many packs of hot dogs and bags of buns would you have to buy to have an equal number of hot dogs and buns? So in other words, uh, how many multiples of 8, how many bags of hot dogs, and how many multiples of 12, how many packs of buns would you have to have the same number of hot dogs and buns so you don't have any left over. You could use least common multiple. This is where this applies, and using prime factorization is a good way to do that. So when we do prime factorization, we're going to use our factor trees. So we factor 6, that's 3 times 2, and when we factor 6, we want to be sure to circle our prime numbers, which is 3 and 2. If we factor 8, we get 2 and 4. 2 is prime, so we make sure to circle that so it's easier for us to identify. And then 4 is 2 times 2. So looking at 6, 6 was 3 times 2, and 8 was 2 cubed, or 2 to the third power, which is just another way of saying 2 times 2 times 2. Now here's the important part, is that you take the factor of the number that has the highest power. So in this case, 2 to the third is higher than 2. So we're not going to use this 2 from our factorization of 6, because this 2 right here is already included in this 2 to the third power. And that's really easy to see when we write it in exponential form, which is what 2 to the third power is. These are called exponents. So 2 to the third power is the highest power, and 3 is also another factor, so we're going to have to use 3. So essentially what this says is that 2 times 2 times 2, or 2 to the third power, times 3 from our 6 is equal to 4 times 2, which is 8, times 3, which is 24. So that means our least common multiple for these two numbers here is 24. Another way we could check it is by using this method right here, where we just list out the multiples. Multiples of 6, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, and 6 times 4 is 24. And you can see that when we list the multiples of 8, we get 24 as well. So this is just a quick way to demonstrate that using your factor trees to find the factor to the highest power for that respective number, using that highest power and then multiplying out to find your least common multiple. All right. So here's a 4 and 25. We can see that we factored it here. 2 times 2, 5 times 5. So 4 is 2 squared, and 25 was 5 squared. So we have to use both because 2 is, well, it's really the only factor of 4. 2 to the second power, and 5 is really the only factor of 5. So 2 times 2 is 4, times 5 is 20, times 5 is 100. Awesome. And then you can see we found that for 25, our fourth multiple is 100, but this factor tree, using it this way, is so great because if we had to list all these multiples, if we had to list all these multiples of 4 all the way up to 100, we would be here forever. So this is why this is a more efficient method, and I hope that we can see it now by using these factors written in exponential form. It was a little more difficult to see when it wasn't written in exponential form, but hopefully it's a little bit easier now. All right. So if you have 3 numbers now, this is also very good because it's going to take you forever if you have to list out all the multiples of 16, 20, and 30 to find the least common. So we did our factorization here using our factor tree, and we got 2 times 2 times 2 times 2. So that's 2 to the 4th power. Let's be sure that's 2 to the 4th power, not 24. And for 20, we have 2 times 2 times 5. So 20 was 2 to the second power, and we cross this out because 2 to the fourth is the higher power. So we use the higher power. We don't use this because 2 to the second is already included in that 2 to the fourth. All right, but we can't forget our 5. We're going to keep that guy in there. And then we have 30, which is 5 times 2 times 3. So 30 was 5 times 2 times 3, so we cross out that 2 because he's already included into the fourth, and 3. We have to include that 3 because there's no other factors of 3, and 5. So now we multiply these out. 2 times 2 is 4, times 2 is 8. Geez, that almost looked like a 6. Let's make sure 4 times 2 is 8. I'm not able to use a pen. I'm using a mouse to write here, so bear with me. 8 times 2 is 16. 16 times 3 is 48. And 48 times 5 is 240. Okay, so we're back. So we found that 240 was our least common multiple for 16, 20, and 30 using our factor tree, prime factorization. And that makes sense because if we look here at 30, if we listed the multiples of 30, which I'm not going to do, you have 3 numbers here. It's going to be way too long, take way too long. 8 times 30 is 240, so that would be the 8th multiple. And here we go down to 20. 240 would be the, well, 10 times 20 is 200, so it'd be the 12th. Because 2 more 20s would be 40, so that'd be the 12th multiple. And 16, well, 16 we'd have to go even further on that. So I'm glad that we're not going to do that, especially when we have 3 numbers. Okay, so that's how you find the least common multiple for a number. Well, 3 numbers, and you're going to go back all the way here and go ahead and see if you can find the answer to this hot dog bun problem there. Good luck.